Okay. Now I did say we can do this without fractions, and I apologize ahead of time. I actually had to switch what I was using to record because the previous thing I was using is not allowing me to create any more videos because of a registration issue. So I am sorry about the weird glowing circle. Alright, so anyway, as I said, you can actually take a look at this problem and clear the fractions. I'm going to show you what that means. Basically, in mathematics, anytime you have an equation, you are not required to deal with fractions unless the denominator has a variable in it. This x is in the numerator as far as it's concerned. It's attached to the 14. There are no variables in your denominators here. They're both variable free. What that means is you can get rid of the denominators. You're under no obligation to use them. Getting rid of the denominators is really simple. What you're basically going to do is you're going to multiply each fraction in the equation and each piece of the equation. So everything in the equation is going to get multiplied. Again, the reason you're actually allowed to do this is because this is an equation. What you do to one side, if you do it to the other, you've maintained harmony. So we're going to get rid of denominators by doing the same thing to everything. And the same thing we're going to do is multiply by the common denominator. You have two denominators here. They're both 15. Obviously, the common denominator in that case is 15. So what we're going to do is multiply each piece of this equation by 15. Okay. Unfortunately, that stays 15x squared. Here, your 15s are going to cancel, and you get negative 14x. And here, your 15s are going to cancel. We get negative 8. 15 times 0 is 0. Now you've got a regular standard equation. A is 15, B is negative 14, and C is negative 8. Only negative for doing it this way is the numbers here get pretty big. And let's take a look at that. You can do this by working out the discriminant first, or you can do it by taking the entire equation at once. I'm going to take the entire equation at once. Oopsie. Sorry about that. Let me know, though, if you want me to go back and do it with the discriminant instead. Okay, so negative b being, and I did it again, I apologize. That should be a 4. There we go. Okay, so negative b, and our b is negative 14, so that entire thing is getting written right here. Negative b plus or minus the square root of b squared minus 4ac divided by 2 times a. Okay, so and again, you can do this with the discriminant. I'd be happy to show you how, but this is how you do the whole thing at once. So x equals negative and a negative cancel. Again, gives you a positive 14 plus or minus the square root. Again, whenever you're squaring a negative, you are going to have to change it to a positive. Negative 14 squared becomes 196. Now, here comes the lovely math that comes from this kind of a problem. 4 times 15 times 8. So we've got 4 times 15 times 8. It gives us 480. Two negatives do become a positive 480. Just like before, I'm just going to go right back to my calculator and add them together. And again, you don't have a calculator, do it on the side. Alright, so 2 times 15 is 30. X equals 14 plus or minus the square root. The 196 plus 480 is already on our calculator. It is 676 divided by 30. Okay. What's left here now is to say to yourself, okay, can I break down that 676? As I've recommended before, go to your calculator, see if it works. We already know it does. We already know that this is a perfect square and that it's 23. Okay, last thing, but not particularly, you're going to break this up. We're going to take the positive version first, so 14 plus 23 over 30, which is 14 plus 23. Okay, hold on one second. I actually apologize, because this is not 23. In our last problem, it was 26. I'm really sorry about that. So let's just change that back to 26. Okay, so we've got 14 plus 26, which is 40, divided by 30, which is 4/3. And of course the subtraction, 14 minus 26 over 30, again negative 12 over 30, which reduces by 6 to negative 2/5. And once again, you've got your two answers. Basically, as you can tell, you get the same amount of large numbers. However, you're not really concerning yourself with fractions. So that's pretty much it.